All right, everyone, we are back. Lab Worksheet 1, Video 4. This is the last in the Worksheet 1 series. Here's our real-life example, and we are on the last of these 4 principles that we need to understand. How to make sure I'm correct. There are 2 methods that I like to make sure that a calculation is correct. Why do I emphasize these? Because in a winery, you don't want to add too much or too little of something to a wine. Too little is okay in some ways as long as you catch the error, because you can always add more. Tough to do after bottling, of course, but before bottling. But if you add too much, it's often impossible to remove that excess from the wine. So we want to make sure our calculations are correct. And here are 2 methods I use. The first method is to cancel units. What does that mean? It means that units in the denominator cancel units in the numerator and vice versa. So if you had, say, a fraction that was 3 grams per liter, and you were multiplying that by a liter, 1 liter, or let's use our conversion factor here, change this, and let's change that to 3.78 liters per gallon. We have liters in the denominator in the first term and liters in the numerator in the second term. Those cancel. And so when we do the math, we would multiply 3 times 3.78 to give us a numerator. And what units remain in the numerator? Grams. So it would be grams, that would be 3 times 3.78 grams per gallon. So we've converted grams to liters from grams per liter here in the first term to grams per gallon. And what made it easy was canceling units in the numerator and the denominator. So let's look at another example of how this works. All right, so method number 1, canceling units. Let's do this example. 2,350 grams, and we're going to convert that to milligrams, so we're going to multiply that by the conversion factor of 1,000 milligrams per gram, and we will do the math. 2,350 times 1,000 is 2,350,000. And what are our units? Well, we're canceling units in the numerator, canceling units in the denominator. So grams and grams cancel, and we end up with milligrams. And that is our answer. It looks right because we're going to go from grams to milligrams. We know every gram has 1,000 milligrams. So our number has to be bigger than 2,350, and it is. It looks good. So in the prior example, we used a couple of principles. And the first one is that any number can be written as a fraction with 1 in the denominator. So if in that prior example, I wrote 2,350 grams, that is the same thing as 2,350 grams divided by 1. And the only value of doing that is it makes clear that the 2,350 is in the numerator. And then when I write it over 1, it's clear that there is a denominator as well. Okay? So for canceling units, it's important to know that there's a numerator and a denominator. But any number can be written as a fraction with 1 in the denominator. So $1 over 1 is just $1. $1 divided by $1, just $1. The other principle is units in the numerator cancel units in the denominator. And we already went through that. All right, so this is just reiterating what we said before. All right, so let's do another example. Canceling units. Considering those 2 principles, we have 3,410 milligrams. We want to convert that to grams. So we are going to use the conversion factor of 1,000 milligrams. Oops, I wrote that wrong, didn't I? I was going to have milligrams in the denominator again. So let me just do that again. Start over. 1 gram divided by 1,000 milligrams. And to make it clear, this first term, the 3410 is in the numerator. We're going to write it as 3410 divided by 1. And if we do the math, then we get 3410 divided by 1,000. We can simplify that down to 3.41. And what are our units going to be? Well, milligrams in the numerator cancel milligrams in the denominator, and I'm left with grams, and that's what I want because I wanted to convert to grams. So there is my answer. Method number 2 of checking your answer is what I call the smell test, also known as the big picture test. Now, this has nothing to do with one's nose. That's a poor representation of a nose. See, there's the eye. This has nothing to do with the nose, okay? This is not a smell test due to our sense of smell. This is simply a smell test or a big picture test, or thinking about the answer and does it make sense overall. All right, so let's look at what it takes to do the smell test. Okay, if we're doing this example, your rate of addition of yeast is 2 pounds per 1,000 gallons. That's the typical rate of addition of yeast in a winery. Calculate the total amount of yeast you would add at this rate to 3,000 gallons. Okay, so that's pretty easy, right? We've got a 3,000 gallon tank, or we have a tank, and in that tank is 3,000 gallons of wine, or juice in this case, because we're adding yeast. So 3,000 gallons. And our rate of addition is 2 pounds per every 1,000 gallons. Well, it's pretty easy to see that we're going to add 6 pounds, right? 2 pounds per 1,000 times 3,000 gallons is 6 pounds of total yeast that we're going to add to the 3,000 gallons of juice. So we could do the math. You know, if we did the math, we'd have 3,000 gallons times our addition rate of 2 pounds per 1,000 gallons. Gallons would cancel in the numerator and the denominator. I could write this as 3,000 over 1. Gallons cancel in the numerator here, in the denominator in the second term, and we end up with 6 pounds of yeast. That's our answer. If we wanted to do the big picture test and see if it made sense, then we do this in our head as much as we can. Well, in this case, it's a simple example and pretty easy to do in your head, right? 2 pounds per every 1,000. You have 3 times as many gallons, so it's 3 times as many pounds, 6 pounds. Everything looks good. All right, easy to do in your head. What about this one? If your rate of addition is 2 pounds per 1,000 gallons, but you're going to add it to 8,000 liters, that's not as easy to do in your head, is it? But I would try it, all right? And so what I would do is, first I would do my math. And so, all right, so let's do the math. We'd add 8,000 liters times 2 pounds per 1,000 gallons. We have a problem here because we have gallons in the second term and liters in the first. So we have metric units here in the first as a measure of volume in the first term, and we have English units here as a measure of volume in the second term. So we need a factor to convert the two. And so we know that our factor is 1 gallon is 3.78 liters. All right? So now what do we have? Well, we've got 8,000 gallons. Let's write that as 8,000 over 1. So we have liters in the numerator here, which cancels against liters in the denominator in the third term. We have gallons in the denominator in the second term here. We've got gallons in the numerator in the third term, so those cancel. And we end up with pounds as the units in our answer, right? Because the only units remaining after we cancel are pounds. So now if we did the math, and I'm going to pause here and do the math, the answer turns out to be 4.23 pounds. Okay, so does that look right? That's the question that the smell test or the big picture test asks us. So ideally we would do this, we would try to approximate the answer by doing it simply in our head. And how I would proceed is, first I would convert 8,000 liters to gallons in my head. Well, how do I do that? I think about this conversion factor here of gallons to liters. That is approximately, my approximately equals sign, 1 gallon per 4 liters. All right, so if I'm just rounding in my head to do the big picture test, I would say 1 gallon equals 4 liters. So if I've got 8,000 liters, I can say, all right, 8,000 liters, if I divide that by 4, that gives me the number of gallons. So that's about 2,000 gallons, right? Approximately. This is, again, just trying to do the big picture test to make sure we're close. So it's approximately 2,000 gallons, and it's 2 pounds per 1,000 gallons. That's our addition rate. So 2 pounds per 1,000, if we have 2,000 gallons, that means the answer is going to be approximately 4 pounds. And what do I have? I've got 4.23 pounds. So it looks like this answer that I calculated, 4.23, passes the big picture smell test. If I had inverted one of these factors here, then I'd get a very different number. And so if the smell test said I should be about 4, and say I was at 400, I'd know something was wrong. So it's a matter of just checking my numbers. It's easy to push decimal points in the wrong direction and end up with something that's 10 times too much or 10 times too little. But if I do the big picture smell test, then I get an idea. All right, it should be about 4 pounds. It is about 4 pounds. I'm in the ballpark. I didn't screw this up too bad. Here's another one. What if I was adding 30 parts per million SO2 to 10,000 gallons of wine and I wrote the conversion factor upside down? So 30 parts per million, we know, equals 30 milligrams per liter. And I'm going to add that to 10,000 gallons. So I have to multiply that by 10,000 gallons. But again, I've got English units in gallons, I've got metric units in liters, so I need to do a conversion. So what if I wrote my conversion factor as 1 gallon per 3.78 liters? Well, hopefully, when I cancel my units, I would catch the fact that I wrote this conversion factor, gallons to liters. This is upside down, okay? So I wrote this upside down. So hopefully I would catch it when I canceled units, all right? But what if I didn't? What if I didn't and I just did the math? Let's see where the math comes out. The math here comes out to be 79,365 milligrams. Okay, so that's my answer when I just do the math. And I'm going to pretend that I canceled the units, but I obviously didn't because I would have caught my error. All right, but let me do the big picture smell test. Let me see if I do this in my head. All right, so I've got 10,000 gallons, right? And I know that each gallon contains about 4 liters, right? Rounding off. So that's going to equal about 40,000 liters. 10,000 gallons is about 40,000 liters. And I'm adding 30 parts per million, or 30 milligrams per liter. So I can multiply this by 30 to check my math, right? So if I do that in my head, well, let's see. It's going to be, I've got 1, 2, 3, 4, 5 zeros, and 4 times 3 is 12. So let's do 12 plus 5 zeros. 2, 3, 4, 5. Now that works out to 1,000,002 milligrams. That's my ballpark big picture. My big picture test said I should have 1.2 million milligrams. I've got 79,000 milligrams. What is going on? That is the kind of question that can be posed by doing the big picture smell test or doing the calculation in your head. So when I find an error like that, I have to go back and say, well, what did I do the first time around? Oh, I see. I wrote this conversion factor upside down. All right. So if I went back, let me go back, and if I wrote this as 3.78 liters, if I replace this with 3.78 liters per gallon, right? If I use that instead, now when I do the math, I come up with 1 million, let me put this in white, 1,134,000 milligrams. All right, 1,134,000 milligrams. That is much closer to the ballpark big picture smell test answer that I got by doing this in my head. All right, so that is what this is good for. Just checking, make sure we're in the ballpark. It catches errors like writing conversion factors upside down. There's more in canceling units. If you need it, look at this link to a video at Columbia University. All right, this is a long video, my apologies, but let's just finish it up and we're done. So let's do our real life example. We're going to add 30 parts per million to 10,000 gallons. So 30 ppm equals 30 milligrams per liter. You've memorized that. Times 10,000 gallons, that's our volume of our wine. We need to convert that to liters, so we will use our 3.78 liters per gallon conversion factor. And let me write 10,000 gallons as 10,000 over 1. Let's cancel units. Liters in the denominator, in the first term. Cancel liters in the numerator in the third term. Gallons in the second term in the numerator. Cancel gallons in the denominator in the third term. And we're left with milligrams. So if I do the math here, and this is the same math as in the last problem, I get 1,134,000. And what units are left after canceling? Milligrams. So this is milligrams. This is milligrams of SO2, right? Because we said here we're adding 30 parts per million SO2. But remember, we're adding it as potassium metabisulfite. So we have to convert the milligrams of SO2 to milligrams of potassium metabisulfite. So I'll take my 1,134,000 milligrams of SO2, and I'll apply the conversion factor for potassium metabisulfite. And you'll remember that is 1 milligram of KMBS, potassium metabisulfite, for every 0.57 milligrams of SO2. All right, and that's why it's important to specify these are milligrams of SO2 that we got in our answer up here. All right, because we're going to replace those with milligrams of KMBS. So when I look at the bottom equation here, I can write the first term here as over 1 to make it clear that milligrams of SO2 in the numerator in the first term cancel milligrams of SO2 in the denominator in the second term. And I'm left with milligrams of KMBS, which is the units I'm looking for in my answer. So now if I just do the math, I take 1,134,000 divided by 0.57, and that equals 1,989,474 milligrams of KMBS. All right, so those are the milligrams I'm going to add. And you could convert that to grams or even kilograms if you want, but we won't do that today. Let's do one more thing though, and just make sure with the big picture smell test this makes sense. So I've got 10,000 gallons. I know that 10,000 gallons is about 4 liters per gallon. That would be 40,000 liters. and I'm multiplying that by 30. So that'll give me, we did this in on the last example. So if I multiply those together, I get about 1,000,002. All right, so it'd be about 1,000,002 milligrams. And we know that the conversion between KMBS and SO2, it's about 1 to 0.57. I can approximate that as 1, so this would be approximately 1 to 0.5, which approximately is the same, which is the same as 2 to 1. So it means to get from milligrams of SO2, which would be 1 at the bottom, to milligrams of KMBS, I'm going to double it. All right? So if I take my 1,000,002 up here at the top, that's my ballpark estimate, and I multiply it by 2, if I double it, then I'm going to get 2.4 million, 2,400,000 milligrams. Okay? Well, is that in the ballpark? Is it past the big picture smell test? It's pretty close. Look, I have just about 2 million. My big picture ballpark test was about 2.4 million. Remember, I rounded here to 0.5 instead of 0.57, which will make my number bigger. It was bigger, 2.4, but it's in the ballpark, right? I didn't get 2.4 in the big picture and have 200,000 in my answer. Or I didn't get 2.4 and have 20 million in my answer. So I'm close. So I'm okay. It passed the big picture smell test. Okay, gang, thanks for hanging in with this long video. A couple more quick points. Important abbreviations, know these. You can stop and read this list. I don't need to read it to you, but be sure you know all these. And for lab safety, on the first day, there's a lab safety handout. I want to make sure you all see that. When you're in the winery, move carefully, watch your head. It's a fairly compact winery with lots of equipment. And I'm going to give you a tour on the first day to show you where the shower is. That's not so we can take a shower after a run. It's so we can take a shower in case we get any chemicals on us. There's very little hazard in the wine lab, but sodium hydroxide we work with, and so it's good to know where the shower is just in case. And I'll show you where the rest of the lab equipment is as well, including the safety eye wash in case you get anything in your eyes. All right, again, thanks for hanging in with this long video. We'll see you in class.